Alright, so today's parabola lesson is we are dealing with inequalities with parabolas. So now we're just not talking about just graphing, we're talking about shading either inside the parabola or outside the parabola. Okay, so we are going to use Desmos. Let's just get rid of these examples here. We're going to use Desmos and we're going to go through some of examples to see if we can try and figure out a pattern here. Okay, so if we use the equation that we started using last class, the 4cy thing. If I have 4cy is equal to x minus 1. We're shifting it over just a little bit. We get that shape. But we don't want equals. We want a inequality. So if I make 4cy greater than that, I shade inside the parabola. What if I made 4cy is less than that? Oop, I don't want that. I want minus 1. Oh, what was that? Minus 1. Oh, so greater than is the blue, less than is the green. So when we have a vertical parabola facing up, greater than is inside, less than is outside. Okay, so what if it was facing down? What if we made them both negatives? So now it's facing down and facing down. Oh, same thing. Greater than is shading inside. Less than is shading outside. Okay, so the vertically makes no difference. Greater is inside the parabola, less than is outside the parabola. So now what if I make it horizontal parabola? So this one becomes x, and this one becomes y. Oop, y. So now I have a horizontal parabola. Greater than is shading inside the parabola. What about less than? What about less than? Boom. Oh, less than is outside, greater than inside. Again, what if I flip it around? Flip it around again. Boom. Ah, look at that. Greater than inside the parabola, less than outside the parabola. So now we have our rule. Okay. So now we can come back to our notes and we can say, anytime you have your equation where you have plus or minus 4cy is greater than or equal to or just greater than x minus h squared, you shade less than, you shade outside. And 4cy, these are vertical. Okay, so you're shading outside. And if you had in the other way, so plus or minus 4cy is greater than or equal to or greater than, you shade inside. You shade inside, depending on if it's positive or negative. Okay, and thus the same rule holds true for horizontal ones. So even if you did this, 4cx greater than, sorry, less than y minus k, you would have either that or that, and you're shading outside of it. Or you have that greater than or greater than, then is going to be inside. Okay, remember, you only have one or the other. This is not a hyperbola. This is a parabola. So you either have this side or this side. If it's positive, it's over here. If it's negative, it's on the other side. Okay, so now we know the rule. Anytime we see that the y side is greater than, we are shading inside. Anytime we see the y side is less than, we are shading outside of our given parabola. Okay, so that was quick and short. So the second part of today's lesson is going to be intercepts and intercepts. So we have our x-intercept, y-intercept, and also two lines that intersect each other, right? Intercepts and intersections, I suppose, and intersection points. Now, just like we did with all the other conics, it is possible to have no intersection points between the parabola and our x and y coordinate. So it is possible that we can have x and y coordinate like this, and then we have our parabola here. Here we have 0 intercepts, right? Or it is also possible to have boom, boom, and then like this. Here we have 1. And then we can also have this, oops, I should use it anyways, where we end up with this, where we have 2, 1, 2. Okay, so this is we're talking about x-intercepts. If we're combining them, then we can have 0, we can have 1, we can have 2, we can have 3. Okay, how can we have 3? Well, if this one keep going like this, then we can have 3. 1, 2, 3. Okay, so 2 this way and then 3 that way. Right? So how do we solve for these? Same as before, you set the x equal to 0 to get the y-intercept, and then you set the y equal to 0 to get the x-intercept, or intercepts, depending on how many you have. Okay? And then, let's do an example with this one. It'll be quick, it'll be easy, because you know exactly what we're doing here. So if we are given 6 y plus 3 is equal to x minus 2 squared, and we are looking for the intercept, so we'll make x equal to 0 over here, and then we'll make y equal to 0 over here. So we end up with 6y plus 3 is equal to 0 minus 2 squared. So 6y plus 3 is equal to 4. So y plus 3 is equal to 2/3. Y is equal to, bring that over the other side, 2/3 minus 3. So we have one y-intercept, which makes sense because it is what shape it goes like this. Right? This is a shape that goes like this, where it is that is at 2, -3. So 2, -3 means that it's there and there. So we know we're going to have 1, 2, 3. So 1 y coordinate down here, and then let's find the x coordinates. So we make 6, 0 plus 3 equals x minus 2 squared. So 6 times 3 equals x minus 2 squared. 18 equals x minus 2 squared. So we have plus or minus root 18 is equal to x minus 2. So 2 plus or minus root 18 are our two answers. Boom, boom. All right. Awesome. So that's all you have to do to find the x and y intercepts. So the next thing we're going to look at is if we had a parabola and we were talking about intersecting with a line. So let's put that as a title as well. Parabola intersecting with a line. Parabola intersecting with a line. Let's see how far that is. With a line. So if we have that example, let's go with well, obviously, how many can we have? Well, we can have a line like this and a parabola like this where we have no intersection point. We can have a parabola like this, a line like this, so we have one intersection point. Or we can have a parabola like this and a line like that where we have two intersection points. So there's three possible answers that we can have. So if we have, let's do an example here where we went 6y plus 3, we use the same one. So that's the same graph as what's up here. And then we intersect it with the line that is y equals x plus 2. Now if I cheat and I go back here, y equals x plus 2 means it is crossing at 2, and it goes like this. So we know at some point it is going to, we know there's an answer, right? Just by a quick sketch like that, we know there's an answer. So how do we solve it? Well, we simply take this, we plug it into here. So we take this answer and put it in for y, substitution. So we have 6x plus 2, oh, not close, plus 3, I mean, plus 3 is equal to x minus 2 squared. So then we solve that out. So we have 6x plus 6 times 5 is 30 is equal to x squared minus 4x plus 4. Then we bring everything over, so we have x squared plus 10x plus 26 equal to 0. Use whatever you want to do, use quadratics, or use factoring, solve it, and you will get your answer, right? Because we know that it will cross, oh, I went too far. We know that it will cross somewhere over here, and it will cross somewhere up here again as this goes up. So because you're using quadratics or factoring, you are going to get 2 answers for that one. Okay, today's a very quick short lesson because you know how to do everything that we're doing in here. The only thing that is new is this properties rule right here, where if you are doing the shading, if y is on the small side, you shade outside, y is on the big side, you shade inside, or vice versa, if x is on the big side inside, x on the small side outside, depending on if it's vertical parabola or horizontal parabola. Okie dokie, so go to it.